Do us a quick favor, guys. Hit the follow, subscribe button. Share this with someone who would benefit from it. And help us grow, as the more we grow, the better the episodes will get. Thanks, guys, for helping us. And let's get into the episode. We're computers. And we can reprogram ourselves just like we can reprogram computers. When we're able to reprogram ourselves, we're able to dictate what we do. I have reprogrammed myself, okay? The way that I think, the way that I consume information, all been reprogrammed. You're seeing a reprogrammed version of myself from 2 years ago, right? The version of myself 2 years ago wasn't as programmed as myself now. Or maybe it was, it was just reprogrammed. I've reprogrammed myself to more of a positive skew.
And he's here. He is here. Cristiano has entered the building. Welcome, wherever you are, to the Old Trafford Theatre.
Alright guys, welcome back to the Sculpt Podcast. Today's episode, we are hopefully going to keep it relatively short. This could be a massive episode. I don't know. It's long. It's scientific. Potentially boring. But this is like the foundation for a lot of philosophies that I probably have. A lot of experiences that I have. This is a breakdown into your brain. It's difficult to understand, but I think that when you understand how your brain works, you put yourself in a better position to understand your next move. I think that's a good way of saying. So with that being said, I've got so much stuff in here. Actually a little bit crazy. May mean nothing to you as well. First thing I want to talk about. We are computers. And you have to hear me out on this. As soon as you understand why I'm saying we are computers, you'll kind of... No, it's not going to be that quick, sorry. Once you listen to this episode and you understand why, you will then agree with the statement that we are computers. Now, I've studied the brain for probably 3 years now. It's something that I recommend most people do. Now, I haven't studied it in terms of a degree or anything like that. I've done notes myself. I've written a few papers on me understanding it, and obviously this episode should be a vessel of which it shows you that I've gone through due research and done my due diligence there. But with that being said, neural networks. Getting straight into it, as I said, neural networks. You might not even have heard of a neural network before, but a breakdown of how neural networks work and why they're considered complex algorithms. So inspiration from the human brain. Neural networks draw inspiration from the structure and functioning of the human brain. In the human brain, there are billions of interconnected neurons that transit signals to one another. These connections allow us to process information, make decisions, and learn from experiences. So nodes, which are artificial neurons. In a neural network, the basic unit of an artificial neuron, also known as a node or perceptron, each node takes input and performs mathematical operations on it, and proceeds an output. This output is then passed on to other neurons. Okay, so it's very easy to it's much easier to think about it when you have a visual. Okay, so when we think about the neuron, it's connected, and the decisions and the actions and experiences are then, it's like a flow diagram essentially. So when the input is received, goes through the neuron, and then it goes into the next neuron, and these all have different pathways. Okay, layers. Neural networks are typically organized into layers: and input layer, one or more hidden layers, and an output layer. The input layer receives data, the hidden layer processes it, and the output layer provides the final result, right? So input, whatever the input is, it could be an action, whatever. Then the hidden layer, so the input layer receives the data, the hidden layer processes the next neuron, and then the output layer provides the final result. So we've got the layers, right? Now, each layer would then have their own delta, essentially, to where that reaction is based. So Weights and activation functions. The connections between neurons are assigned weights that determine the strength of the signal passed from one neuron to another. Additionally, each neuron typically employs an activation function which determines whether the neuron should fire. For example, transmit a signal based on the weighted sums of its inputs, right? So the weight of the input is dependent on the brain's functioning of value or whatever the programming is of that individual's nurturing. So, learning through training. Neural networks learn by adjusting their weights based on the error or difference between their predictions and the actual target values. This process is known as training. So common training algorithms include that's a very difficult one to backpropagation and stochastic gradient descent. Okay. Complexity through layers. The complexity of neural networks comes from their ability to have multiple layers of neurons. Deeper neural networks with more hidden layers can capture intricate patterns and relationships in data. This is often referred to as deep learning. So when there's deep learning, it's much more basic. It's much more deeper than like surface level things, right? The networks have much more deltas. They go into many more different factors, and it's then a much more deeper sense of what that original input was. Okay. Now, I'm not an expert. Okay. I'm not an expert in neurology. I'm not an expert in the brain, right? A lot of these things, I can't, if someone questions me on them, I won't be able to give you a massive reasoning on it. Okay. This is just from research. So the complexity through layers. That's what I went through. So now the universal function approximators. So neural networks have been proven to be universal function for approximators. This means that given enough neurons and appropriate weight adjustments, they can approximate any mathematical function. So this flexibility makes them powerful tools for tasks like image recognition and language translation. So application diversity. Neural networks are used in various fields for computer vision, e.g. facial recognition, to natural language processing, e.g. chatbots, and even in self-driving cars for processing sensor data. Their adaptability and ability to handle large data sets make them essential for modern AI applications. So when we talk about these, neural networks and computers are literally like the same pathways. Now, this is from my understanding. I could be wrong, but what I've explained to you there is how we are computers. Okay, the same processes of how computers work, and the weights of which they go down to the deltas and the neurons and the, as I mentioned in the beginning, so the artificial neurons, right? These same processes happen through our brain. And when we think like that, we can understand how we can program ourselves, okay? Now, a lot of these things are very deep level thinking. We've got to think surface level. So when we think about the weight of an input, the weight of the data, the weight of whatever it is, how can we train our brains, okay? How can I be more efficient with things that I do? Why is it that when I understand a project, I understand it 10 times faster than you? Is that because I've done the meticulous learning phases to make sure that as soon as I hear an input, I do the next 5 steps to make sure that I actually receive that properly? What you do is completely different. You hear it, you forget about it, or maybe you don't pay much attention to it. But the next steps that I take, the next 5 steps that I take, make sure that the weights are more impactful, they go down different neurons, and then therefore that's stored, okay? So neural networks are a complex algorithm that stimulates the interconnectedness nature of neurons in the human brain. They can process vast amounts of data, learn from it, and make predictions or classifications based on what they've learned. Their versatility and ability to handle complex tasks have made them a central component of artificial intelligence and machine learning. So just as we are able to learn, artificial intelligence does it so much better than us, okay? Because they've got like, it's not unlimited. There is limits to artificial intelligence, but we are more limited. And these same processes go on for artificial intelligence, for example, which is much more prevalent in today's society, and we see it everywhere. right? So the brain plays a central and incredibly complex role in processing information and making decisions. So this process involves various regions and intricate networks of neurons. So a simplified breakdown of how the brain handles these tasks is receiving information. So the sensory input, just like before, process begins with our senses: sight, hearing, touch, taste, smell. They detect, the external stimuli. The sensory receptors gather information from the environment. Okay. Transmission of signals. So just like before when we were talking about the computers, the neurons are the basic functional units of the brain. They receive the transmitted electrical and chemical signals. The neural pathways, information travels through the neural pathways, which are then interconnected with highways in the brain. Okay, so they're connected through the weight, the results, and whatever, through those, the sensory inputs. The brain processes and integrates information from different sensory inputs. For example, when you see a red traffic light and you hear a honking horn, your brain integrates this information to make a decision about stopping your car, okay? So when I feel an emotion and there is an action from that emotion, my brain then processes that information. And then our brain, we're habit machines, right? So whenever I have that emotion, my brain will try and, it's an energy efficiency way. So we're habit predicting machines because we want to conserve as much energy as possible. So the reason that we have a bias, the reason why we have a prejudice is not because we are intrinsically wrong. It's because we are intrinsically programmed to think this way because we're saving energy. Okay, so if I'm thinking about this, red bottle cap, and I'm thinking, okay, this plastic, I think that from the way that I'm looking at it, the way I'm touching it, if I was to put it on my desk and smack it as hard as I can, I would probably be able to predict that would hurt. And the reason why I can predict that would hurt is because I've done this with other bottle caps before. And I've done it with metal ones, I've done it with, soft plastic ones, I've done it with the plastic film ones. But I know that from how I've felt this, for how it looks, my brain is telling me that that's probably going to be dangerous. So don't do it. So when there is this recognition and this pattern of perception, we're saving our energy, and you know what? That's not worth my time to find out that end result because my brain is programmed to tell me that this is bad, danger, stay away. Memory and learning. The hippocampus is a crucial structure for forming new memories. It helps encode and consolidate information for later use. Synaptic plasticity. The connections between neurons, the synapse, can be strengthened or weakened through a process called synaptic plasticity. This underlines learning and memory formation. Okay? So the emotional influence. You got to realize all of these words, I'm not going to be able to pronounce the correct way. But the amygdala, I'm pretty sure it's the amygdala. The amygdala plays a key role in processing emotions. It helps evaluate the emotional significance in events and can influence decision-making. Now, decision-making. Prefrontal cortex. So you probably all heard of the prefrontal cortex. The prefrontal cortex is involved in high cognitive functions, including decision-making, reasoning, and planning. The executive functions. Decision-making is a complex process that often involves considering multiple options, weighing pros and cons, and predicting the outcome. The prefrontal cortex manages these executive functions. Now, me reading this, I just realized that the reason why I got into learning about the brain in the first place was athlete mentality, which is Gabriel Dino. Now, if you don't remember him from a previous episode, we have an episode with him where we've talked about setbacks and things like that. Now, when I first discovered about learning about mindset, things like that, he was the first person who introduced me to it. And I have my spreadsheet still to this day from the work that I did about neurology. Now, very basic, but whatnot. I have a much more better understanding of it through Andrew Huberman now, but regardless, just a random thought that I had, remembering that was actually the first, funny that we were talking about memory at the time, but that was the first time that I had kind of been introduced to learning about it. Now, action and response. Motor cortex. Once a decision is made, the motor cortex sends signals to the muscles to execute the chosen action. For example, when you decide to raise your hand, the motor cortex indicates the necessary muscle movements. Okay, so we don't think about that. Me doing this, I can think about instantly, right? That's an instant response. But when we break that down, time that's gone from my brain to actually me moving my muscles, that's rapid. That is so fast, okay? If we're thinking about that of, writing an essay, if I'm thinking about writing my essay, it's going to take ages to do, right? And this is where AI is so fast at it, because just like this is rapid for me, writing a 1,000-page essay for ChatGPT, it's almost like this for it, right? It's crazy. Anyways, feedback loop, continuous process. The brain continuously receives feedback from the body and the environment, which can influence subsequent decisions and actions. Conscious and unconscious processes. Dual processing. Some decisions are made consciously and involve deliberate thought, while others occur unconsciously or automatic. The brain can handle routine tasks without conscious awareness. Now, this is what I'm talking about habit recognition, right? If I see this red bottle cap, my habit recognition would tell me, red bottle cap, bad, stay away. If I see someone who looks like they are a good athlete because they have a great physique, they have an athletic build and whatnot, habit recognition would tell me that these characteristics, they would be athletic. Now, I can be completely wrong, but to conserve energy and to be as efficient as possible, our brains are telling us athlete looks athletic, probably athletic, okay? And this is the difference between our conscious and unconscious thought patterns. So when I'm thinking about training your unconscious, it comes through training the conscious. So the more you train the conscious, the more you're training your unconscious. Now, this is something I have to really, really do a lot myself. Because when you want to retrain a way of thinking, you have to train the conscious. Now, this is what I do with my mental work, okay? Now, the mental work I do is monotonous and it's very boring. And sometimes the immediate effects will never be seen. It's a long-term thing. I'm retraining my brain to think differently about situations, okay? That's where the genius is in it. And now this is what the whole episode's really about, is that this is how we can train our brains. Because we are computers. We are computers. Everything, our situation, everything is accumulated, and we can train ourselves to think differently. Neuroplasticity. I think that a lot of people would have heard of this. The brain's ability to adapt and rewire and form new connections is known as neuroplasticity. It allows us to learn, recover from injuries, and adapt to changing circumstances. Processes are not always flawless, and biases, emotions, and cognitive shortcuts can affect decision-making. In summary, the brain's role in processing information and making decisions is a complex interplay of sensory input, memory, emotions, and cognitive function. It enables us to navigate and interact with our environment, learn from our experiences, and respond to a wide range of situations. Now, something I forgot to also mention was the dual processing. So some decisions are made consciously and involve deliberate thought, while others... I already said that, sorry. Okay. The computer analogy. So, the brain and the computer, as I showed you from part 2 and part 1, they're connected. Not exactly, but when we think about, Elon Musk and Neuralink, you can kind of see how if you wanted to reprogram someone's brain, it's not too far off even reprogramming a computer. Now, me saying that, it is really far off for someone who's actually doing it. But when we think about it in a similar way, they're actually not too far off. Like if I was to, reprogram this bottle to have legs and move, then I'm really far off it because, this is just a piece of plastic and it doesn't have motion, doesn't have emotion, doesn't have feelings, whatever. I can chuck it up in the air and I can predict what it's going to do. But for brains, it's a bit more, if I was to put legs on this, whatever, that's a much more complex process. But when we're talking about brains, computers, brains, similar processes. So that's what I was trying to say with that. But which likens the brain's functioning to that of a computer. It has gained support from various studies in neuroscience. So here are some key pieces of evidence from neuroscience studies that this is a worthwhile analogy. So a study published from the journal Trends in Cognitive Sciences in 2005 of Dehan et al. It discusses how the brain processes information in a step-by-step manner, similar to how a computer processes data. This study highlights in parallel between neural networks and computer algorithms in terms of information process. neural networks and algorithms. So research in the field of neural networks, particularly deep learning, has shown that artificial neurons networks used in machine learning, like I mentioned in page 1, can mimic certain aspects of the brain's functioning. Deep neural networks with multiple layers of interconnection nodes have demonstrated the ability to recognize patterns, learn from data, and make decisions resembling some cognitive processes of the brain. Neuroimaging studies. Functioning magnetic resonance imaging fMRI studies have provided insights into how different brain regions light up and can communicate when processing information and making decisions. These studies reveal patterns of activation and connectivity that can be likened to data processing in a computer network. Electroencephalography, which is EEG studies. EEG studies have shown that specific brainwave patterns are associated with different cognitive processes, such as attention, memory, decision-making. These patterns can be analyzed similarly to how computer algorithms process data. So as I was saying, how pattern recognition, it's similar to an algorithm, okay? It's a difficult concept to kind of get your head around if you don't really know much about algorithms, but when an input is put into the algorithm, that it is then put down the next pathway. If it doesn't go through this one, it'll go through the next, and it's very, very deep learning. But the emerging field of connectomics. So this focusing on the mapping of the intricate network of connections between neurons in the brain, and research in connectomics has revealed that the brain structure and connectivity resemble complex networks akin to the wiring of computer circuits. Neuroprosthetics and brain-computer interfaces, which is BCIS, the development of neuroprosthetic devices and BCIs, which allow direct communication between the brain and external devices or computer, provides strong evidence of the brain-computer analogy. These technologies rely on the brain's ability to send and receive electrical signals, much like computer input and output. I don't know if you've ever done one of those like brain machines. I can't recall what they're called, but I did it once in like year 7 science, where they attached me up to some sort of machine, and they were able to see the state of like joyfulness. I think I can't necessarily remember what it was, but basically the level of whatever they were measuring, they were able to see on the screen. So the guy who was asking me these questions, he was able to then see what my reaction to that was. So there was like a interactive image, which was a direct reflection of what was happening in my brain at the time on the screen. And he would say something, and on the screen you would be able to see what part of my brain would react, and it would be a heat map. And then a certain part of the brain would react, and you would see, oh, okay, that's like, okay, happiness or sadness or whatever. And he would say these different things, and you would see on the reflection of where my brain was, receiving that information. So how the brain might perform various tasks. So further supporting of the idea, the brain has a computational system. While the brain-computer analogy is useful for conceptualizing certain aspects of the brain function, it's important to acknowledge its limitations, right? As I said, the brain is vastly more complex than any computer, and many of its processes are not fully understood. Additionally, the brain processes unique features, such as consciousness and self-awareness, that go beyond the capabilities of traditional computers. Therefore, while the analogy is valuable, it should be used with caution and an appreciation of the brain's unparalleled complexity. Now, as I said, with the AI, we know everything about the software to develop AI. Now, we can't confirm if AI has a consciousness or not, right? Now, that's beyond our knowledge. Very, very much up for debate. Now, I'm not informed enough to say if it does or doesn't. I don't even know if that's a ridiculous statement to say in itself, but for humans, we do have consciousness. We do have these functionalities of which we can't even comprehend or, let's say, understand. We can cut a brain open and we still have no idea where consciousness or whatever comes from. Like, this just we can't comprehend it. Therefore, there is limitations to the analogy, but the analogy in itself it's very surface level, right? We don't need to go into that and where it doesn't line up. Social programming. The brain's ability to integrate information from various sensory inputs is fundamental and it's an aspect of its information processing capabilities. This integration happens seamlessly and rapidly, allowing individuals to make split-second decisions in their response to their environment, right? Now, that's what I was talking about, like pattern recognition and the instant reaction that I have for hand movements, right? I don't need to think about even doing this. This is just happening. I just think, okay, move. Now, this is the type of thing where the whole episode is about, right? You may see no connection between me doing this and me talking about how we can program our brains, but when we are able to program our brains so that our reaction to something is based on a pre-existing response, right? Reaction and response is different. The reaction is prefrontal cortex, and response is... Sorry, I think I have that wrong. The reaction is unconscious, and the response is conscious. Okay, so what I mean by that is conscious is a response. Therefore, a response is something that is a longer process. A reaction is an immediate perception of something. Therefore, you don't think about doing it. Right? If I throw this bottle cap at someone, their reaction would be to probably either move, catch it, or get away. A response, when they see it coming, if I say, "Oi, catch this," or "I'm throwing this bottle cap at you," they're thinking about what their response will be. That's the difference. So when we're able to program our brains to give the desired response that we want, so that anytime that we are given that action, the reaction is the response that we want it to be. But because we don't have time to think about it, then our reaction is immediate and we don't think about it, right? Sensory input. The brain constantly receives input from our sensory organs, including our eyes, ears, skin, taste buds, and olfactory receptors. Each sensory system collects data about specific aspects of the environment. Parallel processing. Once this sensory information enters the brain, it is processed in parallel. This means that the different brain regions simultaneously analyze the input from different senses. In the example you provided, this visual input from the red traffic light and the auditory input from the honking horn are processed concurrently, right? So when I said that the horn and the traffic light visual here, it's an immediate, that's the reaction. So integration occurs when information from different sensory modalities converges in higher brain regions. In this case, the brain integrates the visual information to the red light with the auditory information, the honking horn, to create a unified perception of the situation. Okay, so we're able to then, our brain is seeing that, we react quickly because we know that if we hear this and we see that, that's the action that we should then take, or it's just an inherent thing, we're shocked. Okay. Decision-making. After integration, the brain engages in decision-making processes. In response to the integrated information, it might decide to apply the brakes and stop the car, thus ensuring safety in response to the perceived danger signaled by the red light and horn. As I said, motor response. Once the decision is made, the brain sends signals to the motor cortex, which then coordinates the physical response. In this example, it sends signals to your muscle to apply the brakes and bring your car to the halt. So as I said, with the arm like that, when you hear something and see something, it signals an immediate response to then doing something. Now, that's not a trained response, but it's an instinctive response. It could be trained. A trained response might be when you're, if you're just in a normal car, automatic car, you just hit the brakes. If you're in a manual car, the response, so the reaction is hitting the brakes. The response would be changing gears and whatnot and doing it in the appropriate manner. Okay, that's the difference between the reaction and response. But if you've trained yourself to respond and react in that specific way of which you should, then that response becomes your reaction. Feedback loop. Through its processes, the brain continuously receives feedback from the body and environment. If the initial response doesn't result in the desired outcome, e.g. the car doesn't stop in time, the brain may adjust the response accordingly. So this integration of sensory information is a testament to the brain's remarkable computational power and adaptability. It allows us to navigate the complex and dynamic environments effectively. Additionally, this process highlights the brain's role as an information and processing hub that continually assesses and responds to incoming data, much like a highly advanced computer system. Cognitive biases. Now, this is what I was talking about, and this is kind of where it's like a touchy thing, because you think about the reason why I didn't want to talk about like this being a red bottle cap is because it's like touchy, right? Because racism and habit recognition can definitely be similar. Now, I don't want to go into politics at all, but I'm going to steer away from that as much as possible because that's not my place to comment. I'm not educated enough in political things, and this isn't what the podcast is about. So, cognitive biases and predictive algorithm. Cognitive biases. So, they are indeed mental shortcuts or patterns of thinking that our brains have developed over time to help us process information quickly and efficiently. These biases are often helpful in everyday decision-making and sometimes lead to systematical errors or flawed judgments, right? As I was saying with this, if I look at it, I see it, and I hit it actually, and it doesn't hurt, and it's not dangerous, then that is a flawed judgment. Now, it happens. But we're doing this to conserve energy and be more efficient with that time, right? If I'm betting, man, I would say probably going to hurt. If it doesn't, I think I lost the bet or whatever. I saved energy and potential damage by not doing it, even when I am wrong. Let's delve deep into this concept, right? And explore how some well-known biases like confirmation bias operate. So confirmation bias. This bias refers to the tendency of individuals to seek out and interpret and remember information that confirms their pre-existing beliefs or hypotheses. It's a mental shortcut that allows us to reinforce our pre-existing views without expending too much mental effort. Now, what that can be, and you should see this in a lot of the podcasts that I do. There has to be a lot of confirmation bias in the podcast episodes that I do because I have to live in a confirmation bias world because I have to do everything with 100% because then I can learn from my shortcomings essentially. So, if someone strongly believes that a particular diet is effective, they might only seek out and remember success stories from that diet, ignoring any evidence to the contrary. Influence on decision making. Confirmation bias has a significant impact on decision making, and it can lead individuals to disregard contradictory information, maintain false beliefs, and make decisions that align with their existing views rather than making choices based on a comprehensive assessment of all available evidence. If you really believe in something, neglecting a contrary opinion, it's just going to conserve your energy. Confirmation bias is the conservation of energy, pretty much. Also, ego, ignorance, that's mixed in it. But when we think about it in the brain way and we're thinking about that, it's conservation of energy typically. Research studies and predictive algorithms can shed light on how cognitive biases operate. So algorithmic biases. Predictive algorithms, particularly machine learning models, can exhibit biases similar to cognitive biases when trained on biased data. If training data contains systematic biases, the algorithm can perpetuate and eventually amplify these biases when making predictions. Example, if a predictive algorithm is trained in historical learned approval data that reflects gender biases, it may unfairly favor or disfavor certain genders when making learned approval decisions. Research studies. Numerous studies have highlighted algorithmic biases in various domains such as criminal justice, lending for hiring. For instance, research has shown that predictive policing algorithms can lead to over-policing. Predictive policing algorithms can lead to over-policing in certain neighborhoods, reflecting historical biases of policing practices. Now, that's kind of what I was saying before. That's like the touchy subject. I don't really want to talk about it too much, but that's where the flaws come in. That's where it's not a resolute, concrete. Yeah, this is where like psychology comes into play with it, right? We can't say that it's going to be a complete resolute science in that form. Now, that being said, that's not the best terminology. I can't tell you what the best terminology is. It's not in my vocabulary, but there's probably better ways to say it. But mitigating cognitive biases. So research also explores strategies to mitigate cognitive biases in decision making. So for example, decision aids and nudges can help individuals make more impartial choices by prompting them to consider alternative perspectives or by structuring decisions in a way that minimizes biases. So, for example, providing decision makers with a checklist that encourages the weigh pros and cons objectively can reduce the impact of confirmation bias. Now, what I do is I actually use ChatGPT for things like that. What that could be for you is you could ask your parents, so that confirmation bias isn't there because you're only thinking in your narrow way of thinking, right? Now, it's not a bad thing of just thinking in your narrow way, but when it's a more complex subject, having external opinions can really help you get to the real point that you need to get to. So cognitive biases are a mental shortcut that influences our thinking and decision-making processes. So they are analog. They're analogous way to the way predictive algorithms can perpetuate biases when trained on bias data. Awareness of these biases and ongoing research into their operation is crucial for developing strategies to mitigate their impact both in human decision-making and in the design of predictive algorithms. Okay. Nature versus nurture. Probably heard of it before. So, this debate has been a long-standing and complex topic in the fields of psychology, biology, and genetics. This debate centers around the relative influence of genetics, which is nature, and environmental factors, which is nurture. So, on individuals' development, behavior, and characteristics, let's explore this debate and see how genetics and the environment interact. So, heritability, which is genetics. Research on twins, both identical, which is identical twins, and fraternal, have been key method to study the heritability of traits. These studies examine the extent of which genetic factors contribute to individual differences. So statistics, heritability estimates for various traits such as intelligence and personality typically fall within the range 30% to 80%. For example, studies that suggest that genetics play a substantial role in determining a person's IQ. Genetic disorders, genetic conditions like Down syndrome or Huntington's disease clearly demonstrate the role of genetics in shaping one's physical and cognitive development. Environment. Adoption studies suggest and involve comparing the traits of behaviors of adopted children with those of their biological and adoptive parents. They help tease apart genetic and environmental influences. Statistics. The adoption of studies have shown that the adopted children often resemble their biological parents more closely in terms of traits like personality, intelligence, rather than highlighting the role of genetics, right? However, environmental factors still play a significant role. So what that's saying is like the nurture is there, but the adoption of the genetic traits from the biological parents are still prevalent. Socioeconomic factors. Research has constantly shown that environmental factors such as access to quality education, nutrition, and supportive family environment can profoundly impact an individual's development and life outcomes, which is essentially helping them reach their best version of themselves, right? So when you have these things around, you're able to reach the best version of yourself. Like if we think about it with food, if you want to get to the highest height that you can become, let's say, now we don't know, we can't point at an individual when they're a newborn baby and say this is how tall they're exactly going to be. I know that there's tests and whatnot, but they're all estimates. But if we think about the actual maximum height someone can get to, if they're only able to eat 1,000 calories a day and they need, 1,800 every single day, there is no way that they will be able to reach their pinnacle height. So if we think about it in the same way, someone who is very blessed and benefited from modern day technology, right, nurtured in the right environment, we are able to reach the full potential or close to it. Now, people who are in a less, like a lower socioeconomic environment, then they have less chance of reaching that, which is where the discrepancy between people in third world countries and, the Western world have quite a strong juxtaposition. Okay, epigenetics. The study has changed of gene expression that do not involve alterations to the DNA sequence itself, but are instead influenced by environmental factors. This field has shed light on the dynamic interplay between nature and nurture. So DNA methylation. Environmental factors can lead to the addition or removal of chemical makers, like methyl groups, on DNA affecting gene expression. For example, childhood adversity has been linked to changes in DNA methylation patterns associated with stress response genes. So this is something that my dad actually spoke to me about, and I had no idea about before. So epigenetics. So when you think about genetics, you think it's a fixed thing, but no, actually, according to epigenetics are with your DNA, it can be adjusted. So now this is clear to me now when I think about the studies. I listened to this on the Andrew Huberman episode. So with epigenetics, if you are someone who is a healthy individual right now and you're lean, you don't have any worries with your physical health and you're a good, healthy individual eating the right foods, and then 20 years later you decide to have children and you're the complete opposite of that person, your children will most likely take the DNA of you where you are now, because your DNA has changed to then how you were X amount of years ago. Now, I can't say that with 100% confidence, but that's from what my understanding of epigenetics is. Histone modification. So epigenetics changes also occur at the level of histones. So the proteins around which DNA is wound, these modifications can affect how tightly DNA is packed, thereby influencing gene accessibility. So transgenerational effects. Epigenetics can change, sometimes be passed down from one generation to the next. For instance, the dietary habits of grandparents potentially affect the health of their grandchildren through epigenetics mechanisms. So that's what I said there, right? In summary, the nature versus nurture debate is increasingly viewed as a false dictum. Both genetics and environmental factors in complex ways shape the individual's traits and behaviors. Heritability studies, adoption studies, and research in epigenetics provide valuable insights into the interplay between these factors. Moreover, it's essentially to recognize that genetics loads the gun, but the environmental pulls the trigger, emphasizing the significance of both nature and nurture in human development. So that they have to play together. And now, you may be thinking, what relevance has this got to do with sculpted? But this is a very deep level of thinking. A surface level way of thinking is, now how can we use this to better ourselves? Now that we know this information, right? So we know about nature and versus nurture. Okay, how can we nurture ourselves to reach the threshold that we know that we can get? Okay, if we know our nature, if we know what our, through the process of elimination, we kind of learn what our nature is, right? Going through the most rawest form of us as children, what were our patterns then? Can we integrate them? Can we stop them? Can we nurture them? Now, this is how we use that for our advantage. So if we know that our nurture, so our environment, our things like that, aren't very good for us, and we know our nature doesn't like those things, then what is something that we can do? So let's say I have a tendency to not like this thing, and it does this because when I'm in this environment, so they counteract each other for a negative effect, right? Using that to our benefit, we would then change that. So if I am in Australia and the football there isn't very good because of the coaches or whatever it is, now I'm not saying that's the case, but let's say this is for the sake of the video, right? Then the nurture would say, okay, I should get into an environment where I have that ability. The nature would say, okay, wherever I am, I'm probably going to make it work to a good degree, but the nurture would then make it work to its best degree. So when I use these two in cohesion, we get the best result. Okay, the next, and I think second last, okay. The free will paradox. Now, I think we're at 40-something minutes. The free will paradox is a paradox of free will within the context of being a programmed computer. And it is a profound philosophical and scientific question that has fascinated thinkers for centuries. So let's explore this paradox and examine determinism, compatibilism, and neuroscience studies that shed light on decision-making. Paradox of free will. The paradox arises from the idea that if our brains operate like programmed computers, making decisions based on algorithms and neural networks, it challenges the traditional notion of free will. The ability to make choices independently of external factors, if our actions are determined by the physical processes of our brains, can we truly be said to possess free will? Determinism. Determinism is the philosophical position that all events, including human actions, are ultimately determined by previously existing causes. In a deterministic worldview, every choice and action is a result of prior conditions, making free will an illusion. Compatibilism. Compatibilism is a philosophical stance that seeks to reconcile determinism with free will. It argues that even if our choices are determined by external factors, we can still have a meaningful concept of free will. Compatibilists often define free will as the ability to act in accordance with one's desires and intentions, even if those desires and intentions themselves are determined. Neuroscientific studies. Wait, let me just stop that. So, determinism, compatibilism, complex. Not easy to completely understand, but from my understanding, it's how you grew up, it's the environment, all of these different decisions in your early life, whatever it is, they then form your basis for every single decision that you make, right? If we think about like trauma and those things, they then base the actions of which an individual may make because of previous things. Such a difficult concept to get around if you've never heard of it before, but like for me, I'm new to it as well. Neuroscience has provided intriguing insights into the timing of decision-making processes, some of which challenge our intuitive sense of free will. So the Libet experiment in the 1980s, Benjamin Libet conducted an experiment that suggested brain activity related to a simple voluntary action, like moving a finger, occurs before a person reports a conscious intention to perform that action. That actually legit just happened to me. That was weird. This raised questions about the timing of conscious decision-making. Neural prediction studies using functional magnetics resonance imaging, which is the fMRI, which I talked about before, and the EEG, which I talked about before, have shown that the brain can predict a person's decisions several seconds before the individual is consciously aware of making the decision. This suggests that the brain may initiate actions before we are consciously aware of them. Now, I think that from what I even said there, you could probably predict that my finger was going to move up and down again. Now, I don't know if you saw, but I made sure that I didn't do that because for the sake of the video and the podcast, for the listeners watching, I've been doing my finger up and down in my palm, but when I read that out, I made sure that I didn't because prediction analysis would say that I'm probably doing it again, right? I made sure not to. Now, we've got a German word, Bereitschaft potential. The Bereitschaft potential, or readiness potential, is a gradual build-up of electrical activity in the brain that precedes voluntary actions. It was discovered by Hans Helmut Kornberg and Luder Decker. This potential seems to indicate that the brain begins preparing for an action before the individual consciously decides to act. These studies have ignited debates about the nature of free will and the relationship between consciousness, awareness, and decision-making. While they challenge the traditional notion of free will as absolute, they don't definitively prove or disprove it. They suggest that our sense of free will might be more complex than previously thought, involving a combination of both conscious and unconscious processes. Similar to how I was saying with this, I must have been able to think about it a few milliseconds before even me doing it. It's very rare that the things that I do aren't thought about previously. It's just such a hard concept to get around. But when we think about that, how can we use this to benefit us when we're sculpting? Well, if we're able to reprogram ourselves to have the right reactions and responses, then it's an immediate thing. And if we're able to make sure that the way that we think, the way that we act, everything of which I do, I've programmed myself to think in this way through consciousness, to then program it through unconsciousness, the results of everything of which I do should be accumulated in the right direction. In conclusion, the paradox of free will in the context of being a programmed computer is a rich philosophical and scientific topic. Determinism and compatibilism offer contrasting perspectives on the nature of free will, and neuroscientific studies provide intriguing insights into the timing of decision-making processes. The debate continues to evolve as our understanding of the brain and consciousness deepens. This is the last topic. Hacking the human computer. Hacking our own programming for personal growth and change is a fascinating concept that involves consciously altering our thought patterns, behaviors, and responses. Here are some key practices and examples. As I've said, it comes to conscious level. Then you go down to the subconscious or unconscious. I think it's subconscious. I think I've been saying unconscious all the time. Unconscious is where you're out. Subconscious is when it's like you don't think about doing it, but you do it. Okay, mindfulness. Mindfulness is the practice of being fully present and aware of the present moment. It involves observing your thoughts and emotions without judgment. By practicing mindfulness, individuals can become more aware of their automatic thought patterns and emotional reactions. Over time, this awareness can lead to greater control over one's responses. For example, a person who regularly practices mindfulness may notice that they have a tendency to react with anger in certain situations. With mindfulness, they can catch this automatic response and choose a more constructive way to react. Now, when I first started mindfulness practices, it really helped me with my awareness. Now, when I do them, it's a bit less because I've reached a level where it's a much slower progress, but it still helps. cognitive behavioral therapy, CBT. CBT is a therapeutical approach that focuses on identifying and challenging negative thought patterns and beliefs. By working with a therapist, individuals can learn to reframe their thinking and develop healthier thought patterns. For example, someone with social anxiety may undergo CBT and learn to challenge their belief that they are always being judged by others. They can replace this belief with more realistic and positive thoughts, leading to reduced anxiety. Now, this is like what I do with my mental work. It's exactly what I do. I'm replacing my subconscious with conscious, but then I'm programming my conscious to be subconscious. So when I put it in a positive, when I reevaluate the subconscious and I rewire the subconscious to be a positive, then I've trained my subconscious to be something else now. My reaction is positive. Meditation. Meditation involves various techniques that promote relaxation, focus, and self-awareness. Regular meditation can help individuals gain control over their thoughts and emotions, reduce stress, and increase overall well-being, similar to the mindfulness. A person who meditates regularly may find that they are better able to manage their stress levels and maintain a sense of inner calm, even in challenging situations. So it's reprogramming of the physical being, essentially. Success story. So Tim Ferriss, the author and entrepreneur, Tim Ferriss has shared his journey of hacking his own programming for personal growth, similar to how I have. He's known for his experimenting with various techniques and practices such as intermittent fasting to improve different aspects of life. Now, as I said, intermittent fasting. I'm starving right now because I'm intermittent fasting. Now, what is that doing? It's reprogramming my brain to see that this feeling, this emotion that I have, I'm hungry, but I'm not reacting upon it. That is what I'm reprogramming. It's okay to have this feeling. That's it. I'm reprogramming. What meditation is, okay, I'm aware of this. I'm hungry. Am I going to act on it? No. Oprah has openly discussed her transformation from a troubled childhood to becoming a media mogul. She credited mindfulness and self-reflection as key tools in reshaping her mindset in life, which is interesting. Hacking one's programming is not about changing who you are, fundamentally, but rather optimizing your potential and becoming more self-aware, which is the nurture part, right? It involves recognizing challenging automatic responses and beliefs that may no longer serve you. In conclusion, practices like mindfulness, cognitive behavioral therapy, and meditation provide powerful tools for individuals to consciously reshape their programming. These practices can lead to personal growth, improved mental health, and a greater sense of well-being. Success stories from individuals like Tim Ferriss and Oprah Winfrey demonstrate the real-world impact of these practices and personal transformations. Now, that was a long episode, probably around the 50-minute mark now, but we're computers. And we can reprogram ourselves just like we can reprogram computers. Now, I hope you've got the main key points of how you can take action. I think that I don't need to go over it again, but when we're able to reprogram ourselves, we're able to dictate what we do. I have reprogrammed myself, okay? The way that I think, the way that I consume information, all been reprogrammed. You're seeing a reprogrammed version of myself from 2 years ago, right? The version of myself 2 years ago wasn't as programmed as myself now. Or maybe it was, it's reprogrammed. I've reprogrammed myself to more of a positive skew. But anyways, guys, do with that what you will. I hope you enjoyed this one. Long episode, probably quite boring, but I hope that you got value from this. Share it. Ask me questions. I'll do my best to help. But as I said, I'm not a genius at this. I'm quite a novice at this. But for the research, I hope that you understand where I'm at, my understanding. You know, I'm nowhere near Andrew Huberman, nowhere near him. But I'm aware, I'm trying to improve, and I'm reprogramming. Anyways, guys, subscribe, leave a like, share, whatever you do. It's all appreciated. I'll catch you in the next episode.